Thank you, Pam, and good evening, and thank you everybody for joining us. I hope you all had a lovely Passover and still got some sleep after last night's earthquake, in case you are in Los Angeles. It is my pleasure to welcome you to our latest edition of our ATS Southern California exclusive interactive program featuring Technion alumnus Eliad Peretz, who's the lead researcher for new space missions at NASA's Goddard Space Flight Center. I see a lot of familiar faces and names. In addition to our community in Southern California, I am delighted to welcome friends from Seattle to San Diego to Scottsdale. We may live in different cities or states, but what we share in common is a passion for the Technion. For those who don't know me, my name is Michael Stoyer, and I'm a board member of the American Technion Society here in Southern California. I was introduced to the ATS about 7 years ago, and as I learned about the Technion, I realized it represents a perfect intersection of two of my greatest passions. Professionally, I've worked in tech all my life, and I'm interested in all things technology and innovation. But perhaps more importantly, I'm a passionate Zionist. Growing up in the small Jewish community of Amsterdam, the Netherlands, as the son and grandson of Holocaust survivors, the importance of a strong, resilient, and self-sufficient Jewish state of Israel was something that I understood from an early age. When I learned about past boycotts of Israel, I realized that she could never simply rely on the willingness of other nations to provide for her defense, food, water, energy, medicine, infrastructure, or technology. Israel would always have to be able to fend for herself. Thankfully for Israel, I was not the first to come to that realization. So did the founders of the Technion. The Technion is Israel's oldest university and is often called the MIT of the Middle East. No other university has contributed more to the building of a nation than the Technion did for Israel. And in some ways, it is Israel's single most important institution outside of the government. At a time when many Jews were barred from technical or scientific training across Europe, the Zionist movement knew there was a need for such training so that they could build and create a nation. Thus, the Technion was founded in 1912, a whole 36 years before the founding of the state. Technion leaders started labs that led to its computer and electrical engineering departments today. Its faculty inaugurated an aeronautics department before the country even owned a single airplane. And Technion welcomed successive waves of immigrants to build a university centered on excellence. Technion's researchers and alumni have been at the forefront of groundbreaking innovations. Technologies critical to the defense and security of the state of Israel, such as the Iron Dome, were born in its labs. And so were life-saving medicine for Parkinson's and cancer. The Technion is also responsible for one of Israel's most desired and successful export products. It's second to none technologists, researchers, and scientists. And we are delighted to have one of Israel's proudest experts with us here. Tonight, Eliad will share with us the challenges that instilled him with the right stuff to launch from his childhood in Afula, Israel, to NASA, where he leads some of the biggest space endeavors humanity has ever undertaken. I've had the pleasure to speak with Eliad over the past months, and his story is truly inspiring, and we are all in for a treat. 2021 so far is shaping up to be a big year for space. Most recently, NASA was in the news with its Perseverance rover landing on Mars, a project that Eliad was involved with. And just a couple of weeks ago, Israel simultaneously launched 3 nanosatellites into space, which just so happened to be built and developed by a team at the Technion, including members of the Faculty of Aerospace Engineering. This faculty is the only one of its kind in Israel and has educated leaders of Israel's military, defense, and commercial aviation industries. Over the years, the faculty and its graduates have contributed to Israel's missile guidance and defense programs, drone technology, the National Space Program, and more. It has played a critical and unmatched role in the country's long-term security and economic success and has thus long been a national priority. Eliad is a proud alumnus of this esteemed faculty, earning his bachelor's degree in 2013. I won't go into detail about his bio, as I will leave that to Eliad to share his unique personal story. We'll start in a minute, but a few housekeeping rules before we begin. Please make sure you mute yourself during the presentation. We also suggest that you watch this in speaker view for the best experience. And after the presentation, we'll have time for you to ask questions. And at that point, we'll ask you to literally raise your hand or your digital hand so that we can call on you. And when you'll be called on, please unmute yourself, or you can type your question into the chat and I'll be happy to ask it for you. I now invite you to sit back and enjoy your cocktail and our conversation. And Eliad, please take it away.
Sure. Thank you so much, Michael. Can you hear me, everyone? Good. Let me share my screen for a second, just to make life easier for everyone. And please let me know when you can see my screen.
See your screen.
Okay, thank you so much. Okay, so first of all, I'm so happy to be here today and share the evening with all of you. I wish I could drink alcohol now, but I have a 1-year-old and a 3-year-old, and they have a tendency to wake up in the middle of the night. So I'm going to stick to water. So cheers to all of you. Let me just make sure I have everything ready. I'm sorry. There we go. Okay. So again, I'm excited to be here today. I'm excited to share my story, and I'm even more excited to hear your questions and just engage in a dialogue with all of you. So during my presentation today, I'll try to touch on 2 different topics. The first one is my journey. How did I come to be what I am today? What are major stations in my life? And those pictures you see in the background should give you a feel of what's coming at you, but I'm going to keep them that way, just as pictures at this point. And all of those are major stations in my life, and I'll get to share more with you about them. The second part of my presentation would focus on what I do today, how I reach to be a part of the National Academies of Sciences, how am I finding myself involved in chasing and finding other Earth-like planets around other stars, how am I involved in building some of the largest space telescopes to ever be built by humanity, and what do I have to do with figuring out the Hubble constant or the rate of expansion in our universe. And it's kind of a very jumpy story from place to place, but I think at the end, you'll see that I could see it coming since the age of 5, but don't want to go too early on that. So maybe I'll begin with just a little bit about what I do. So if someone asks you, oh, you listened to that presentation, but Eliad, but like, what's his thing? Like, can you give me 1 sentence or 2? So to understand what I do, you really need to better understand what NASA does. I'll start with the 3 divisions I'm not a part of that are a part of NASA. On the top left, you can see an image of a full body plane as it enters into a wind tunnel and tested for its lift, drag, and other physical properties that we want to measure. And what NASA is responsible to, among other things, is the civilian aeronautics field within the US. So that means the Boeing 747s you fly in, the command towers in the airport, the protocols of communication between planes and ground stations. All of those things are managed and monitored and developed by NASA mainly, and invested by NASA. And that is an arm that is not so well known across the public, but it is one of the major priorities of the agency. So again, the Aeronautical Research Mission Directorate would be that one. At the top right is the one that you probably hear about the most, the Human Exploration and Operation Mission Directorate, which is responsible for the astronaut program, for the International Space Station, for the soon-to-come, kid you not, 2024, like set your clocks to the Lunar Gateway and our journey back to the moon. And I probably will talk about that a bit more if we have time. And at the bottom left, there is the Space Technology Mission Directorate, who is responsible to develop all the future technologies we will need in order to facilitate the missions that we want to pursue, whether it would be human exploration-based missions or robotic missions or whatever. Most of those technologies take decades to be developed, and there is an entire dedicated directorate within NASA that does that. But the 4th directorate, which I'm a part of, is NASA Science Mission Directorate. And NASA Science Mission Directorate is the one that leads the way and points to the goals that the agency should achieve, or at least would like to achieve. On the top left, you can see one of the branches within our Science Mission Directorate, the Heliophysics division. And the image captures the Solar Particle Probe, which you probably heard of lately. as it launched a few years ago to study the sun. On the bottom left, that would be the Earth division or Earth Sciences division, which is mainly geared at examining both the Earth itself, so looking down, but also understanding space weather and how the sun interacts with Earth and other bodies, and just maintain track of our of the planet's physical properties. So you all know of the temperatures maps that we always see, or the cloud coverage when you hear about a typhoon or a cyclone or a tornado coming in. So those beautiful images that come from the top typically come from the Earth Science Division. But the picture you see here is of a mission that almost no one heard about, but it's probably one of the most exciting missions ever in the Earth Science Directorate. It's called ISAT-2, and it's a small spacecraft that carry lasers, 532 nanometer lasers, that shoot at the ground. Now, this spacecraft fly in an orbit that makes sure that the laser track of the spacecraft covers the entire Earth every 90 days, and it measures the height of ice on the entire planet. And it gives us a mapping, a dynamic mapping of how ice sheets, both depth and shape, are changing with time. So if you hear about a giant piece of ice broken from somewhere, it's not because there is a single spacecraft looking at that place. It's because ISAT-2 has alerted the system that something is happening, and then an auxiliary spacecraft is then turning its cameras down to Earth to better figure out what's going on there. On the bottom right, probably one of the biggest pieces of news you've seen lately is the planetary division, which is responsible, some of us call it planetary, some of it called the solar system division, depends on which angle you're coming at it from, but they're responsible for any body in the solar system that is not the sun or Earth. And that includes asteroids, other planets. And in the image, you can see Perseverance, the rover, with its drill bit going kind of down to the ground. This is, of course, an animation. This is not a real image. But the planetary division is responsible for really some of the most major achievements, at least, well, humans ever known when they came to learn or study other planets. Let me tell you about one discovery that came from a very unexpected place. We had a spacecraft flying to Jupiter to study its magnetic field and its atmosphere. But along the way, let me take a step back. But in order to survive around that planet, it needed to have a giant solar cells. So those giant arrays of solar cells cross through the space all the way to Jupiter, only to find out that many of the solar cells that they carried were hit by small pieces and grains of dust. So the scientists, this is, by the way, in a paper that was published like 2 weeks ago. So this is kind of out of the oven. They managed to count the number of hits, and from that to build a profile of the dust ring around Earth that we see when we look up to the night sky. So I don't know if you get to see the night sky in California, depends on light pollution. But in some cases, if you look up the sky, you see the Milky Way, that's very clear. But one additional thing you'll see, there is like an orangey glow in the sky that goes down up. And that's what most of us call the exozodiacal, the zodiacal dust. And we always thought that the zodiacal dust was created by early formation processes of dust evolving around our star. And as planets form, that's the dust that was left. But that spacecraft, Juno, that went to Jupiter, actually figured out that by counting the number of impact and the size of grains hitting its solar cells, that the dust that we see in the night sky is actually an atmospheric dissipation of dust from Mars. And they were able to track both the belt and the movement of Mars to calculate its density and then reconstruct it back to the sky, which led us now to the conclusion 2 weeks ago that in fact zodiacal dust was not created by early processes, but is still created and still generated by dust released from Mars into space. So that's an interesting discovery lately happening that is not related to Mars rover and has nothing to do with the reason that the mission was launched for. It was just like people looking at data and trying to figure out and explore what's happening in our universe. which is the case for many NASA missions. We fly with a stated goal, only to learn that what we do now is much different than what we thought we will do. On the top right, set your clocks again to October this year. The largest telescope humans ever built is going to be launched. It's a 6.5 meter infrared telescope. It's called the James Webb Space Telescope. And the stated goal, again, is to study the early universe and find the earliest stars that existed and galaxies and so forth. But in reality, a 6.5 meter telescope can do basically everything you'll tell it to do, as long as you have time to look into the sky. This thing is, when folded, is in the size of a bus. It's going to be loaded into a rocket the size of multiple buses, and then launched 1.5 million kilometers away from Earth to the stable point that we call L2, which is the Sun-Earth equilibrium point. Probably one of the most exciting missions of our generation. This mission started probably 3 decades ago. I have the privilege of working with the chief scientist for this mission. His name is John C. Mather. He's a Nobel laureate in physics. I like to describe him as the person who figured out how the universe was created. He's my boss, so I enjoy him every day. And he tells me stories about how this thing started 30 years ago and where we're at today. So it's kind of amazing to see that. So where does Eliad sit? Eliad sits in the astrophysics division, who is responsible for the James Webb Space Telescope, on the top right. In reality, I wear 2 hats. One of my hats is within the astrophysics division in the science directorate. And the second hat is within the Space Technology Mission Directorate, where I act as a technology program manager. So I live a double life. I get to develop technologies for missions that will come in the near future, but at the same time, I get to learn more about what are we trying to achieve, what are the scientific goals, and gets to shape them as we design the new missions. And that's my official role within the agency. Okay, so I'll kind of dive a bit deeper into what I do. Within the astrophysics division, we have 3 very distinct questions we're trying to answer. And you would learn that about NASA as kind of you dive in more and more, is that we have very defined goals. And we tend to put them in writing, and we tend to make them short, no more than 3 sentences. Just because we believe that for a large organization to march towards the same goal, you have to have a clear understanding of what it is you're trying to achieve. So the first question we're trying to answer is, how does the universe work? And specifically, we're interested in probing the origin and the destiny of the universe. So, for example, we want to understand how the universe began. We understand that the universe is expanding. We understand that what we see with our eyes is not enough to explain all phenomena we see, and therefore we deduce that there is dark energy and dark matter. I don't want to go too deep into this, but this is kind of less in my field, but definitely within astrophysics. The second question we are trying to ask is, how did we get here? What do we mean by that? So if the first question dealt with the origin of the universe, this is more about figuring out, how do galaxies form? How do stars form? How do they die? What is the makeup of our universe? And this field is a vibrant field within astrophysics, but still not very much where I'm at. The third question is where I'm at. We're trying to answer the question of, are we alone? And specifically, we're trying to discover and study planets around other stars and explore whether they could harbor life. And what I mean by that is we're trying to understand if we could chemically analyze, by looking at other planets, their composition, and from that, understand if they can support life as we know them. It does not mean we're looking for green people walking on Mars. So this is a very heavy scientific question. The ability to even observe those planets is challenging, and I'll get to talk more about that maybe in the question side. I have some backup slides. So what does Eliad do? Eliad works within NASA, within the astrophysics and the Science Technology Mission Directorate, and he is searching for other planets that might harbor life. So that's kind of the 1 sentence or 2 sentence run-up of what I do at the agency. So up until here, everything was kind of shiny and nice, and you see the pictures of very well done. But now we kind of jump into my journey, and I'm kind of changing the rhythm of my presentation, because people like to talk about their successes, but they less like to talk about their failures. So this is my story. So this is where I started my life. This is a 3-floor building in the Valley of Israel in a city called Afula. And what you don't see in this image is you see those pink kind of pillars at the bottom. They are there because in 1981, a year before I was born, there was an earthquake, and the entire building was kind of basically cracked in the middle. So they had to reinforce the building, and I was living on the 3rd floor on a 1-room apartment with my family. With, kid you not, we are a family of 6 kids. So 4 kids sleeping in 1 room and then babies in the other room. And my father, at the year of 82, joined the Lebanon War, so there was no father in the house for a few years. And of course, back in those days, my mom had to stay home, so we started from a very humble beginnings. I found myself at the age of 5, because I was born in December and basically gained a year, starting my life at ultra-Orthodox school, a Chabad school, which teaches no math, no English, a lot of reading, Torah, but nothing even close to science or anything else in that direction. And this is kind of the place you start asking yourself, like, okay, like how could this journey could even happen, like in real life? And the answer to that starts with family. So my grandfather lived in Amoshav near Afula, and one of the first lessons I've learned in my life was determination. So my grandfather used to own olive trees, many of them. In fact, the field you see here has a 25 and 25, so 25 trees in 1 row and 25 rows, that's 625 rows. And then for each one of them, someone needed to go down next to those kind of roots you see there and cut all the weeds that are called pigs. Now, I assure you that in the summer, this thing is covered with branches, and cleaning each one of those things take about, let's say, few hours. And when you know you have 625 trees left, you learn something about discipline as you do that. So I really did not like school when I was in the ultra-Orthodox school, and decided to just keep going with my grandfather to the field every time. And one of the most interesting things I've learned other than discipline here is the cycle of life in nature. Specifically, I've learned that for us to be able to harvest enough olives from those trees, there is a 2-year cycle of low output and high output, which kind of taught me I have to plan ahead in advance in order to do something in life. And that's kind of where that started. Few years down the road, my father is coming back from the Second Lebanon War, and the entire military is being moved into the Negev, and my family moves to Eilat. And for me, the years in Eilat were years of self-reflection. So I find myself going to not ultra-Orthodox school, but religious school, so less tight. And I just get to rest. I kind of don't care about school. I go to the beach with my friends, I play volleyball, whatever I want to do, and I forget of the existence of studying at that point. And for that, it gave my life at least a serious break from the pace that I used to take. Before I get there, as I get to the age of 15, I understand that I have to start pressing the gas if I want to do something with my life. And I knew I always had an attraction to space and aerospace engineering. And I applied to flight school and the military, and find myself very fast joining the Israeli Air Force, starting to fly planes. And of course, 3 months before the end of the course, I dropped. And that's kind of my first major failure in life. Only to go back, join the military, join the ground course, starting officer school, and then drop again. So the failure kind of, not a failure, but not succeeding, definitely in what I'm trying to achieve, kind of continues. And as I try to move forward, I try to be accepted to the Technion, but what do you know? They don't accept me on the first application. So I find myself going to the pre-academic center at the Technion and study for a year and a half because there is a war. The Second Lebanon War erupted in the middle of this entire thing, as it would happen, like in my life, exactly in the moment you don't want it to happen. And we find ourselves going out and coming back, and I spend a beautiful year and a half here that prepares me to kind of start my undergraduate degree at the Technion. And I cannot talk more about how important this institution is. Most people don't even know it exists, but it allows people that come from non-traditional backgrounds to actually do something with their life. So a good place to think about when you think about investing in people and giving them a chance. I then start my education at the aerospace engineering faculty, going through rough 4 years, 4.5 years. But at the end, graduate with my bachelor's in aerospace engineering, better understanding what I want to do. I mainly focused within this program on rocket design and spacecraft design. And I understand that I'm actually trying to be in a place where I'm sitting in between science and engineering, and I don't do hardcore engineering all the way, not hardcore science. And I'm trying to enable science by making better engineering systems. Kind of, that's what I do today, basically. One step back, sorry. This is also where I meet my wife. So my wife is a Jewish American who was born in Silver Spring in Maryland. And she comes to the Technion under a Fulbright scholarship. And we meet at the Technion. She is developing solar cells at one of the material science labs. And we start dating and kind of understand that we want to be together. She leaves to California, start her graduate program, only to understand that she want to come back. So she lives with me for another year at the Technion. At the Neve America dorms, kid you not, Americans paid to build those dorms. We lived in for a year. And then decided together to move to the US so she could pursue her graduate program. So I land on, I think it was November in Ithaca, New York, to the coldest winter that they've probably seen in a while. It was so bad that the Ithaca Tourism Bureau wrote this kind of notice on the website: due to this ridiculously stupid winter, Ithaca invites you to visit the Florida Keys this week. Basically giving up on what they can do. And I can tell you more about like minus 22 degrees Celsius winters that last for 6 months and snow in end of May. But let's keep that for a different time. And I'm, as you saw, I was raised in Eilat. So very tough time for me. And as I kind of try to figure out what I'm doing in Ithaca and trying to be accepted to different positions or just to the master's program or whatever, I basically do not succeed in most of my endeavors. And I decide to join this lab, which I kid you not, is managed by Technion alumni, Hod Lipson, within Cornell, the Creative Machine Lab, and that's where I get my first break. I decided to focus on research topics that are interesting for NASA, specifically the development of light solar cells to support long-range space missions to the Planetary Science Division. And that's the place where NASA kind of spots me and got me the beginning of funding to be a visiting researcher. And then as I move forward with my project, suddenly publications come in, technology developments kind of kick in, and the agency decides to adopt me into the agency. Within I would say nearly 6 months to a year, I move into Goddard Space Flight Center and start as a low-level developer of technology within our nanofabrication facility. Within probably 7 months, I'm able to develop my first detector that would fly in space. That success leads to two teams I'm leading to develop two different technologies, which then both succeed, which then leads to me getting a promotion. And then as I go up the rank and the story kind of starts swirling, I get to manage 5 different spacecraft at the same time being launched to different places. And when some of those succeed and some of the problems keep going, I'm being basically, John, the Nobel laureate, kind of reached out to me and asked me, do you want to work on something together? And I'm like, give me a second. But in the back, I'm like, oh, yes, this is happening. This is the real deal. And then I find myself basically being pulled into an entire world of mission planning and developing, technology development. And as the years go by, the story kind of keeps exploding. With more successes come the appetite, I guess, in my case. And I just find myself in the eye of the storm. So I'll stop here. I'm not sure how long I was talking for, but this is 10:34. So I'm going to stop it here.
Thank you, Eliad. Thank you so much. Your story is really unique and inspiring. And as I sort of alluded to in the beginning, people like you and you specifically are really Israel and Technion's proudest export products. So hope we'll be hearing about you getting a Nobel one day. We will open it up to Q&A to the audience in a little bit, but I'm going to abuse my privilege of holding the mic by asking you a few questions first myself, and I'll try to not hog it for the rest of the session because I easily could have so many questions. But you mentioned just earlier at the beginning the James Webb Telescope that you worked on. Or that you're working on. And in a recent interview, the well-known physicist Mikio Kaku said that he believes that the James Webb Telescope that will launch very soon is likely to find alien civilizations on other planets, and that reaching out to those would be a terrible idea, quote unquote. Since you're actively involved in this project or in this mission, what do you think of both those assertions, that it's likely that you'll find alien civilizations and that reaching out to those would be, quote unquote, a terrible idea?
Yeah, I really think that with such high claims need to come very strong evidence, right? So if someone claims such a big claim, you need to back it up with strong enough evidence to prove what they say. And I think in this case, it's not an even it's even the assertion of what will happen is an unknown. So it's unclear to me that what's said is indeed going to happen. And I don't want to hypothesize about whether things like that could happen. My immediate reaction is we are really in the business of doing hardcore science. We're in the business of analyzing molecular compositions. We're in the business of taking reflected light measurements of planets. We're in the business of taking measurement using equations to derive phenomena or better understand our universe. So I'm trying to be very serious about what I do. I hope this answers your questions in some ways.
Well, it certainly answers sort of the part of what you expect to get out of the mission. And since you don't believe it's likely that you'll be sending emails to alien civilizations soon, I guess you're not commenting on the terribleness of that idea. Let me ask you another question. The Lucy mission, are you involved with that?
No, but they're one corridor under me, and I'm very much interested in what they do. So we talk a lot.
Right. So the Lucy mission, as I understand it, is going to visit 8 different bodies in our solar system, which is a new record, and it's named after Lucy, the famous fossil that we all learned so much about our ancient past from. What does NASA expect to learn from the Lucy mission?
Yeah, so I think to answer that question, we need to understand why do we care about asteroids or other bodies that are non-planetary within our solar system. So if you take a second and think back about what I said earlier, the process of formation of our solar system, right? Like the very beginning when our star was engulfed with dust and planets were just starting to merge and form themselves. It's not just planets that were created, or many small bodies that were created, and those small bodies could be in some cases treasure chests that tells us about what happened so long ago, right? So for example, when you see bodies that carry water on them, and you see the water evaporate in space, or you see bodies that are composed of heavy metals. So each one of those bodies that you examine, for example, Bennu or the Hayabusa 2 landing or whatever, you learn more about the history of our solar system. So that's, as I understand it, that's the main driver behind the Lucy mission, just on a grander scale, right? More samples, more stations, better understanding the process of formation. Yeah, I hope, was that enough, or do you want me to elaborate more?
No, I think that's helpful. I mean, and the expectation is that it's going to be as sort of groundbreaking, a series of discoveries as Lucy was for sort of understanding human history.
Yeah, you never know, right? Because let's say you fly and you see the same rocky structure that you saw in Bennu, for example, right? Or you see and you don't see you don't see any traces of water, but you see heavy elements. So if that's the case, it just reinforces the story as we know it and the dominating theories as of now. But I think some people in the lower corridor have an idea that that's not the case, and they chose their target wisely to make sure that they see things that people don't expect to see. And that's where I'll stop. I don't want to spill the beans, but I can tell you there is a reason for what they chose to do.
Sure
the target selection. Yeah.
I'll ask one more question and then I'll open it up. So I don't know if you watch For All Mankind on Apple TV, whether you're interested in that show or not. But it follows NASA scientists and astronauts, and the basic premise is that if the Soviets had landed first on the moon back in the 60s, the Soviet Union would have basically not fallen. And the US would have had a competitor in space all this time since the 1960s. And as a result, we would have advanced much further in space than we have today. Do you think that the competition or the lack of competition has stagnated us? And if so, do you think that the increasing competition from countries such as China and India, and perhaps maybe small Israeli nonprofit teams like Space IL, are a positive driver for innovation back at NASA?
Yeah, so I think when I typically get those questions, so the first thing I say always is space is big enough for everyone to coexist. Like really, there is so much to discover. There is so much to learn. We don't have to.
But the space race was a real thing, though, right?
Oh yes, yes, yeah. So the second thing is as long as the competition is healthy, right? I'm for it. So for example, if you see multiple landers coming down to Mars, and because of that, you need to better understand your schedule, your scientific goals, your landing location. If it pushes you to be better, then that's great. If we could collaborate, it would be even better, right? Just utilizing human resources in a better way. And there is something to be said on how tension between nations increase the investment and resources put into scientific endeavors. And I'll stop there.
Thank you. Let's open it up to the audience. And I don't know if, let me see. If anybody has any questions, please either raise your hand physically or digitally. I see Janie. Please go ahead, Janie. Yeah, you have to unmute yourself.
I cannot hear yet.
No. Janie, you're still muted.
Okay, so the problem was I'm on this new laptop that I have, and I don't know how to work on them. I'm so used to pressing stuff on the screen that when you have to do something different, it's a little difficult. So your story is fascinating, Eliad. And aside from meeting your wife, which was probably the big bonus of going to the Technion, I'm just curious, what was it about the Technion that attracted you, and did you study aeronautical engineering there or something else? What was the big attraction to the Technion? What made the Technion so unique that you wanted to go there?
Yeah, so that's super interesting question, because I believe that every student that, or at least any student I know that went to the Technion, have a love-hate relationship with it, right? It was hard, it was challenging, it made you not sleep at night, but you know that you came out of it better. I think that my first steps towards the Technion started with, we don't think you can make it, like you could never get there. I don't want to go into the specifics, I can go deeper, but there was the perception that the place is so good that people like me had no place in it. So that was kind of one driver. And the second driver for me was the topic. There is a single aerospace engineering faculty in the entire state of Israel.
Mm-hmm.
So there isn't any other place to go to if you want to do anything that has to do with rockets or spacecraft or have any real life experience on any of those projects. So the combination of both of those things and the location of the Technion, which was very close to a big part of my family who lives in the Valley of Israel, played a big role in what I do. After I went into the Technion, I think the biggest reason I stayed there is the fact that I really fast kind of understood that the Technion teaches you how to do things by yourself. You cannot trust the lecturer or the professor to teach you. It's not how the Technion takes. You need to be able to open a book, study a topic from zero, dive into it as deep as you can, and the test that you'll have is going to be as deep as they can. And that specific skill set served me very well in life. Up until this day, like if I need to design a space telescope, like I dive into the optics with a book that I found out by myself somewhere in some basement. And I do not need to sit in a class for 3 weeks to figure out something. And I have the ability to dive deep. I think one of the things, though, that with all the good that the Technion does, one of the weak spots for the Technion is the teaching system, right? Like the institution is so focused on research that it sometimes forgets that a part of the process is to teach. And that's another field that I see a lot of kind of interest and resources are being put into it from the outside, where we have different ways to make sure that good professors stay, and and that there are programs that can actually teach professors how to teach. So I hope that answered your questions, and I didn't go too far around other topics.
Well, thank you very much. You know, it's always good to hear the good, and it's always good to hear the suggestions for improvement.
Yeah, and thank you for the question. Nice to meet you.
Nothing is perfect.
Yeah.
We have a question that sort of connects to this in the chat from Lisa. What was your first interest before aeronautical engineering? Were you ever interested in any other studies within engineering?
No, I really don't kid when I say that from the age of 5, I knew I was interested in space, in aerospace engineering, aviation, from launches I've seen on TV, like all of you, to just images that came from Hubble, to any kind of input you get from that space field. It just attracted me to it. So I was never too attracted to other fields. I did have, and I still have today, an attraction to business, but that's a very different field than the field I'm at. In some ways, yeah. So.
I was going to say that actually connects very well with another chat question. What are your thoughts on the commercialization of space? And since you're so interested in business, when are you starting your commercial space agency?
Yeah, well, I think that the agency encourages collaborations between industry. So we are both the customer and the investor of many of those companies, right? Like we would invest in them taking risk in developing systems that we think that we need to use. And a part of our stated goal within the agency is to advance the civil space industry in the US, right? That's a part of the reason we exist. But you can see the living proof of why this yields good outcomes. Just look at SpaceX, right? And launch prices declines like from the 80s until now. That tells you everything you need to know. Of course, this is just one thing. There are probably 100 different products or services that you never heard of that we use every day, like communication, right? Or just the chips, or any other fasteners or low-tech aluminum pieces you never heard about, all commercialized for the purpose of dropping the price. It doesn't mean we invest less in science. It only means we can do more with our money. So I'm very pro investments in industry and just making sure that we understand the role within the ecosystem that we're at.
Great. I see a question from Larry Herman. Larry, please unmute yourself and go ahead, and nice to see you here.
Thank you. Thanks, Michael. I have a question about your background. And as you described it, I'm going to make an assumption and you tell me if I'm wrong. Going to a Haredi school and later a Mamlechti Dati school, my guess is that your background in mathematics and quantitative areas and analytics probably wasn't that great when you were growing up. So when you came to the Technion, you probably had undeveloped math skills. My guess is the people that you're working with at NASA for the most part are completely different. They probably had a good math background early on in their life. And it leads me to wonder if we're not missing opportunities for people who didn't have the opportunity early in their life to not make the assumption that they can't do it. When I went to graduate school, one of the first things one of my professors said is, if you're taking this math for economists course in graduate school, forget it. You're already too far behind to ever catch up. But obviously that wasn't your case.
Yeah, I think that I'm the living proof that what he told you is not true. But let me kind of dig deeper. So somewhere at the age of 15, I understood that I have to strengthen my math skills. And I took an entire year and focused on math and English with an external school. I didn't kind of tell it in my story, but I basically had a 9-to-5 job, which I used all the money from to pay for an outside of the system school to teach me math between 5 and 8 every day, so I could go to my math AP and finish my entire high school diploma by the age of 16. So I did have a deficit until the age of, let's say, 13, 14, but I kind of woke up at that age and really fast understood what I wanted to do. And that led me towards making sure that those skills would be strong. The second thing that happened is I went to the pre-academic school at the Technion, which then reinforced my math, physics, English, and other hardcore, I would say, science basics, and instilled them in me at a very young age. So in fact, I came to the agency probably stronger than most people. And I can see it until this day, every time we do something. The fact that I didn't have the preparation in advance on a young age actually made me work twice as hard, and to make sure, like, there are people who study and they study equations and they kind of come out of class and 5 years later they forget everything. Like when I studied basic things like trigonometry, like I took a ruler and went outside and measured bridges and made sure I understand what I do. Kid you not. I did the same thing, by the way, with my cousins who never had those opportunities, brought them to the Technion, bought them rulers and made them measure the bridge outside of the library in front of the management building. So yeah, I hope this answered your question. I know I didn't fully answer it, but just to give you a feel.
Thank you.
Any other questions? Victoria.
Thank you, Michael. Thank you, Eliad, for your presentation. I was just wondering if you had a dream project that is out there for you that you could tell us. What would be your dream project?
Oh wow, that's That's a great question, because I really feel that what I do is like I live in a dream, right? This is not reality. Like within the agency, flying spacecraft, like hunting for other planets. But I do have one more. I'm currently in the process of being I'm going through the screening process to the astronaut program, so that might happen. We'll see. I passed the first 2 stages, so I'm waiting for stage number 3. That's kind of my, it's not that my day job is bad, don't get me wrong, but there is something to be said for exploration being done with your hands and feet. So that's definitely one of my kind of dream positions or dream. I don't even call what I do a job or a position, to be honest with you. It's just not there. Like you see that like I do this all the way into the night, into the morning. When I get back pictures from the North Pole of things happening, I'm like, yes, like keep sending them to me from the engineers that fly the spacecraft we built or devised. So that would be one of them. The second one for me would be the discovery of another Earth-like planet on sunlight star. Like that's really the material that the next Nobel is made of. So if I have to put my eye on something else, that would be that one. Hopefully there is a chase. I didn't talk about this here, but there is a hunt. It's a global hunt, and you can make a TV show about the kind of money, power, systems, centers, space agencies all across the planet trying to be the first people to do that. But that could be a whole different presentation.
Thank you.
Sure.
Thank you, Eliad. I see. We'll do one more question, and then I know it's almost our stated end time, and it's very late on the East Coast where Eliad is. Aaron Herman, go ahead.
Thank you, Michael, and thank you, Eliad, for talking to us today. I was just curious about your job. How much of your work is sort of very innovative in its nature, in the sense that you get to not just follow some, path that's sort of predetermined where you kind of know where you're going, but you get to actually test out things and say, hey, what if we did this, or what if we built that, and maybe even be allowed to fail from time to time? Is that something that you have the opportunity to do in your job? Yeah,
it's what you're saying is super interesting, because in space there is a very strong tension between innovation and survival, right? Space is a very unforgiving, I would say, environment. Radiation, heat cold cycles, like every small mistake that you do, you will pay. You will pay with money, you will pay with time. But regardless of that, I can tell you that I have the freedom to, for example, let me give you just one example, to decide I want to fly a spacecraft at a distance of 200,000 kilometers, pointing a beacon down, like a laser beacon that we're building, pointing down to a ground-based telescope, aligned with a different star, to observe through it so that we can discover other planets, right? And that's probably a $80 million mission that is a high risk, no forgiven at any kind of anything. So that's kind of one step. And the second one is on the fundamental physics of creating new instruments and devices that can help us better understand the universe. So let me be specific. Like if you want to develop a special camera or detector or something that would be able to read a phenomena you've never seen, right? So gravitational waves, LISA, for example, it's the epitome of like, what are you doing? Who said it would even work? Like you need to fly in a formation to a 1 millimeter. Nobody promises you anything. It's like somebody pulled $250 million on it, and you're like, you're doing your best. Like the entire team is working just to survive the deadlines and then live within the budget, and to try at the end of the day to measure the crashing of 2 black holes into each other. It's really on the verge of imagination. But can you imagine any other country or an agency within that country that will allow them to develop such mission concept to measure astronomical phenomena? I just like, really the US, we went through some hard times in the last few years, but there is no other place. Like one of the reasons I'm in the US is because of that. Like this is the place where dreams happen. Like this is the place where you can dream a landing on the moon with a team, where you can imagine launching a bus-sized telescope to study like old stars. Like this, it doesn't happen anywhere else. It's not because other nations don't have the funding, it's because they've decided not to do that, right? Like other nations, some nations are as rich as the US, but they don't have a space program that is this big, right? So there is something special to be said about the US and NASA and the way in which they allow not just me, but most people within the agency to kind of chart a path and with a career. Yeah. So I hope this was helpful.
Thank you, Eliad. I couldn't think of a better note to end this on than that. That was a wonderful thought. And thank you for taking time out of your very busy schedule to be with us tonight. And I know it's almost 11 p.m. And thank you for being such a great ambassador for Israel and the Technion, also over at NASA, and all you do for and with NASA. It's really been wonderful to learn about your personal story and hear about your work. And looking forward to you taking us to new frontiers, either scientifically or in person on the next mission.
And thank you, Michael, and thank you all for coming here today. I'm very excited to be here. Thank you.
Awesome. We look forward to hearing about your work and successes in the future. And thank you to everybody for being here with us today. I hope today's program renewed your pride for the Technion. And please save the date for our next exclusive program for the ATS Southern California community on April 28th at 10 a.m. featuring Professor Shulamit Levenberg, who's the Dean of the Faculty of Biomedical Engineering. She's a powerhouse and a leader in tissue engineering, diabetes, regenerative medicine, and 3D printed meats, just to whet your appetites. If you have any questions, please don't hesitate to contact Pamela, Senior Director of Development at ATS, or your local ATS staff person. And enjoy the rest of your night. Thank you very much.
Bye, everyone.